we get this done, we'll have nothing for 2 weeks. You can enjoy your election, your voting, and then we will come back 2 weeks from now, and we'll be refreshed and ready to jump into internal controls. Okay, so let's take a look here. We want I think we only have one more to do. I think this is it. Okay. So let's go ahead and do this one. Number 6. Oops. %10% is our risk of incorrect acceptance. Here are the ones we found that have problems. Of these 3, 2 of them are wacky. One of them is well behaved, and we appreciate that, but 2 of them are a little bit strange. So let's go through. This first one, I don't know if you guys remember from last, actually, we didn't work on this last week, did we? It's from 2 weeks ago. There's something strange about the first one. What is it? What's odd about this first one?
The audit value is more than the book value?
Yep. This is an understatement that we're not supposed to be able to catch with this method. When we do find an understatement, we ignore it. We don't consider it to be a problem at all. The projected misstatement is 0. There is no misstatement. And that one's kind of, as an auditor, that one is the one that bugs me, but that's the method. So when you do find an understatement, we say it's 5,200, they say it's only 5,000. They're understating it. We're not supposed to find that. And because we're not supposed to find it, we throw it back. Number 2 is a normal one. That's the one we like. This is an overstatement. We say it's 15,000. They say it's 20,000. So this is an overstatement. This is exactly what we're supposed to catch. And the higher that they make that overstatement, the more likely it's going to get caught by this method. Okay. What is it? 75,000. I want to check my math on that. I think the projected value, I think we multiply out 15 divided by 20, I think it's 0.75. I think it's 75,000. And then the projected misstatement would be how much?
$25.
Yep. So this was a normal one, a normal misstatement that we would generally find with this, and that is that it is an overstatement. That's what we're supposed to be finding, overstatements. And the book value is not more than the interval. So it's kind of well behaved, and we can just put in the projected misstatement. Number 3 is a wacky one. Oops. Oops. Number 3 is wacky. Why? What's odd about number 3? Geez, I've forgotten already. The book value is greater than the interval. This is 100% certain that this one will be caught. You know, this will cross at least one interval. It could cross two possibly, but it'll definitely cross one. Now, when this happens, when the book, where do these things keep coming from? I keep getting these ghost things here. When the book value is greater than the interval, we take the actual misstatement. So book is greater than the interval. Oops. So we take the actual misstatement. Which is 108,000 minus 95,000 equals, does it equal 13,000? So this is, I'm going to change this. I'm going to make these green. So we don't do the ratio thing for this. We take the actual misstatement. And by the way, this is one of the reasons why this method is good. You know, if this, you know, in this case, they overstated it. When they went over 100,000 on this, they walked right into this being caught. Because anything over 100,000 will automatically be picked. Okay, so those together will be our projected misstatement. 25 and 13 is what, 38? And this is our best estimate as far as what it's off by. It might be off by more, but this is our best estimate. So what's the value of this thing? So this is 2 million. Our best estimate is that this is off by 38,000, but it could be off by more because it's a sample. All right, let's go to the basic precision. I think this is way down here. Basic precision. Bring it all the way back up. Wow, is that a big 12, 11? Let's make these all 11. Okay, basic precision. I gotta redo this. You know, I didn't redo. I redid this not too long ago. I don't know why I'm. I didn't do a better job. All right. So we got to take our interval. And our interval is how much? What's the interval?
100,000.
Yep, 100,000. And we're going to multiply it by our reliability factor at 0. Okay, so let's see, we're incorrect acceptance is 10%. So we need the 10% at 0 for the reliability factor. So 10%, 0, 2.31. So 2.31 is going to be our, we're going to multiply it. And this one, this I copied that. Obviously, I did not. So 2.31. So this will equal our basic precision. $231,000. Now this is if we had no errors, no misstatements at all. It could still be off by 231,000, and that's just because it's a sample. And because we don't take 100%, there is a possibility that it could be off by more than, by some amount, even if there were not any errors. So this is basically if there are no errors. And you'll notice down here, we're taking it, the number of misstatements is 0. So this is really saying, look, at 0, we still have a possibility that this might be off a little bit, even if there aren't any misstatements. So this one is as if they're lost here. This one is if they're, basically if there were no misstatements. Now we do have misstatements, so we had to go to the incremental allowance. But if we had no misstatements, we would still have to use that basic precision because this is a sample. Okay, the least fun thing of this whole is the incremental allowance. So we're going to come down here. Now, let's go up here first before we go down and grab our incremental allowance, because we don't have to do the incremental allowance for all of these. Okay, I'll grab the first one here. We don't need it for that. Of these other two, there's only one that we need it for. Which one is it? The 25,000 or the 13,000? Which one do we need the incremental allowance for? You can put it in chat if you want. Oh, come on, flip a coin.
Number 2.
Yep, very good. Yeah, the well-behaved ones, like this one, well-behaved. Oops, don't do that. Don't do that. The well-behaved ones are the ones we have to do the incremental allowance for. So this one is a kind of a normal one. We multiplied it out. There wasn't anything wacky with it. The normal ones are we do the incremental allowance. This one, we don't do the incremental allowance, and you say, well, why don't we do the incremental allowance? We don't do the incremental allowance because there's nothing else in that interval that could go wrong. It covers the entire interval. There could not be anything more wrong in that interval than there already is. It's off by 13,000. There couldn't be anything more wrong with it. So there is no incremental allowance. It can't get any worse than that. Whereas this one, this is 20,000. There could be more things in there. And again, the idea is that if you find errors, it makes it more likely that there are more errors. If you don't find any errors, then there's a possibility that it doesn't have any. Whereas if you find one, you go, okay, now we know it's possible to have errors. So this was the only one that's included. So we only need to do one of these incremental allowances. So I'm going to knock these out right here. What did I do? Oh, I know. I think I got to delete the delete rows. Okay. So we only need one of the incremental allowance. So here's where we're at. We're at the 10%. We're going to do just the first one. We're going to do the overstatement of 1 minus the overstatement of 0. There was one misstatement that is incremental. So 3.89 minus 2.31 minus 1. Don't forget that. That's just part of it. I think it has to do with degrees of freedom. I used to know how they calculated that, but I think it's degrees of freedom. Is why they minus the 1. That's usually when in statistics, that's almost always what it is. Whenever you see -1, degrees of freedom. Uh, I gotta turn on a light because my calculator runs on, it's a solar one. Okay, so 3.9 minus. Okay, so 0.58. And we're going to multiply that by our misstatement. So the size of the misstatement matters. The bigger the misstatement, the more likely that we have bigger misstatements overall. Now we only have one that we're going to have in here, so that's the 25,000. So this 25,000 is only one that is going to go in the incremental allowance. So this one will be 0.58 times 25,000. $14,500. So that's going to be our incremental allowance. And again, this is extra because when there's errors, that means there's more likely that they will have more errors overall than if you don't have one. And these three things together, I'm going to copy this down. We'll go into our upper limit on misstatements. Okay, so let's see. So we 500. $283,500. Okay, so yeah. So this is what we would have to compare to our, so with the book value, 9,000, 200,000. So we had to compare it to this to see if it was material or not. That's a judgment call. And by the way, judgment calls, if they generally don't test those on the exam, and basically when you have a judgment call, you kind of have to go with whatever they say because it's as long as it's as long as it's a possibility. So, 283,000, that's quite a bit. And it might be material, maybe it's not. But regardless, we should all get the same number. We should all get that 283,500. Is that what you guys got, by the way? 45. Yeah, I think that's right. Okay. So that's how we do those. And again, it's not easy going through these, but this is way easier, believe it or not, than the classical sampling. It's way quicker. It picks the sample for you. It finds overstatements. Well, let's go down here. This is the kind of advantages and disadvantages. So monetary unit sampling. When I was going through, they talked about it like it was the greatest thing. Whenever you can use it, use this because it's the best one to use. But it's really not. It really depends on the what you're looking at. If you're looking for overstatements, it's great. If you're looking for understatements, it's terrible. It can't be used. Understatements are ignored. Okay, so the advantages. If they have a very small amount of errors, you generally have a smaller population size, and it can be significant. It can be half as much. And I can tell you from testing, when you're doing testing of accounts and whatever, there's nothing more disheartening than going through, you pull a sample of 248, and you're going through these. And generally speaking, by the time you get to about 50, you know which way it's going. It's either going to be you haven't found anything, but you still have another 100 and whatever, 80, whatever it is, to do, or they're a complete mess. And, so it is, the sample size a lot of times just intuitively as you're going through it, you kind of know where it's going. So anyway, it can significantly cut down the sample size. It can cut down the sample size by half or more, which is huge. It saves a lot of time. A lot of time spent auditing is testing. And if you can get the same answer with doing half the work, let's do that. So it can really, if you're looking for only for overstatements, it can really cut down the amount of testing you do. And you can be just as, we're talking, if you're at the 95% level for both classical sampling and for monetary unit sampling, and you can get that same level of confidence with half the work. Well, why wouldn't you do it? But it can only be used for overstatements. One thing is it automatically stratifies the sample. In other words, it automatically picks larger items first. The larger an item is, more likely it's going to be picked. And generally, it's easier, it's quicker to use than classical sampling. Picking a sample size, picking the sample, all that stuff is done for you. Okay, disadvantages. Big one, can't be used for understatements. The second one is also significant in that if you do run into a problem, you can't expand it, the sample. And I'll talk about classical sampling for just a second. In classical sampling, the larger the sample, the more sure you are, right? And that's the same thing with probably proportional size. But for classical sampling, let's say that you pick 200 items and you come up with there's a problem. Well, one of the things you might want to consider is maybe our sample does not represent the true population, right? If you're at the 90% level, let's say, well, there's a 10% chance that your sample does not represent the sample as a whole. And that's just statistics. You can't get away from it. So that bell curve thing, if you're at 90% level, so you say, okay, well, let's audit to the 95% level and see what happens. At the 95% level, you're going to take a bigger sample, you're going to be more sure of it. And you can even go up to the 99% sample. All you got to do is pick some more items and use a random table. You pick them randomly, and you can get to the 99% level. You can go from the 90% level to the 95 to 99, and then you really know whether generally speaking, whether your sample is the population as a whole. And it might be the ones that you pick, the more ones you pick, maybe is not misstated anymore. Now, that can't happen for monetary unit sampling because the sample size, you say, okay, well, I'll go from the 10% down to the 5% or to the 1% or whatever. The sample size determines the interval. It changes the ones that you pick. The interval is how many times how many chunks you cut this into. So the sample size determines the interval, and that determines the ones that you pick. And because of that, the original ones that you picked may very well not be the ones that you pick when you change the sample size. So it's really difficult, and oftentimes what you'll end up doing is simply going to classical sampling if there's a problem with it, just to be more sure of what you're doing and that you can actually expand the sample more easily. So you can't expand it. If there is a problem, then there is you can't expand it. It's not easy to expand. You basically have to completely do another sample of it at a higher level, because the interval will change. Let me write that in here. The interval will change. And that means that different items will be picked. And basically you have to throw out two. You'll notice, let's go back here. These misstatements are all based on the interval, right? You did we got this misstatement, it's based on the interval. So this came out to 75,000 out of the 100 intervals. So the misstatement was 25. This interval changes, this all goes out the window. So it is a problem that you can't expand it. Okay, classical sampling. The first one we did. If there is a higher occurrence of misstatements, classical sampling has no problem handling that. So if there is a negative, excuse me, if there is uh, a lot of misstatements, it simply goes into the averaging of them. And also, if there are misstatements that go in both directions, overstatements and understatements, like it really is kind of random, this method will kind of give you a more accurate picture of it because, some are higher, some are lower, just the way it is. And they will probably end up with a more accurate because you're not going to ignore the understatements. So if the misstatements go in both directions, it will definitely give you even if there are more errors, it will definitely give you a more accurate picture of it. This is an odd statement. This is not from me, by the way. Items with negative balances do not require special consideration. Generally speaking, you don't have negative balances in most things that we talk about. And what I say by that is if you have accounts receivable, a negative balance in accounts receivable means it's an accounts payable. It's not a receivable at all. It's you owe somebody else. So if you have a customer that has a negative balance, you can't have a negative, you can't have a negative asset. You can go down to zero, but you can't have a negative asset. You can't have negative trucks. You may not have any trucks, it'll be zero, but you can't have negative trucks. So usually if there is a negative balance, almost always that's going to be a reclassification rather than a throwing it in with the rest of the things in the sample. So a negative balance is almost always going to be a reclassification, but you'll see that stuck in there. Negative balances it can handle. Big plus is it can be used for understatements and overstatements. It can be used for anything. And the sample size can be easily expanded. If you get a number that's off, you can double check by grabbing a bigger sample and getting more sure. At 90% level, you can go up to the 95% level pretty easily. Just grab a few more items. And if you want to go up to 99% level, you can grab a few more items and get up to the 99% level, just to make sure that you got, everything's right. Okay. Disadvantages, a lot more work needs to be done when you're first doing it. And if you have accounts that vary wildly in value, you need to stratify those. You don't need to stratify them for monetary unit sampling, but you will have to do it for this. If you want to get the larger numbers, and different audit firms will have their own ideas about what that means. There's some firms that say if you at least half the dollar value, and there's some other ways that they do it. So you grab larger items. Basically, the items that would be material would almost always be picked if they are if the size of them by themselves would be a material misstatement. You always look at those. Okay, the auditing standards do not advocate one technique over the other. They are simply used in different circumstances. And again, that's a little bit different than when I went through. They were saying, use our monetary unit sampling. It's the best one to use and blah, blah, blah. But it's only good in some circumstances. It's only good for overstatements, and it's only good generally when there are fewer errors in the sample. And I think I told you this, the monetary unit one, they've actually had it on the CPA exam where you have to go through kind of what we just did, those last two problems or whatever. They have had I believe those actually came off an actual CPA exam. So that's one that they've kind of tested beginning to end. Whereas the classical sampling, they usually don't have you pick samples. They don't have you calculate sample size. They will say, okay, you're going to use the difference estimation, or you're going to use the ratio estimation, or mean per unit. They will give you those and say what would be the projected misstatement. But they generally, I don't think they've ever asked for you to calculate the sample size, and they've never asked you to actually pick the sample. They never actually go out and go to a random number table and go pick a sample from it, even though that's what you do in real life. Any question on that? Okay, so I think that one's done, right? Hey, my screen's not working. It froze there for a second. And we're done with it. Okay, so that one can get turned in. Hey, look at that. We're done. Woohoo, hour early. But anyway, so we'll start clean 2 weeks from now. I don't want to start something and then pick it up 2 weeks later. So anyway, turn that in. If you've already turned the test in, obviously don't turn it in twice. But make sure you get the test for 5 and 6 in, and let's do this Friday. Any questions? Oh, and again, just to make sure everybody is on the same page, no class next week. Elections on 11/5. So we will not have class next week. You guys should all go vote. And yeah, so no class next week. I'll send out a reminder too. Any questions? Okay, turn in the monetary unit sampling, and that's it. And I'll see you guys in 2 weeks. All right, good night.
Good night.
Good night.